Hey Pre-Calc, welcome back. Hope y'all are well. Our objective today is going to be to find arithmetic series. I've got the checklist on the screen. You know what to do from here. First pause on the screen. Can you try this warm-up for me? I would just like for you to write down the formulas for a sub n for both arithmetic and geometric sequences. Go ahead and hit continue when you're ready to check your answers. So arithmetic means that you are adding a common difference each time to get to your next term in the sequence. So if I want to find the nth term, I take the first term and then I add that common difference n minus 1 times. So if I want to find the 100th term, I take my first term and I add d 99 times. Alrighty? Similarly, for geometric, I multiply a number each time to get to the next term in the sequence. So I would start with my first term and then multiply that common ratio r n minus 1 times. So again, if I want the 100th term, I would start with the first term and then I would multiply r 99 times. Now I want you to really see these similarities to certain functions here. Arithmetic sequences are analogous to linear functions where your common difference, your d, is like your slope of your line. That's your rate of change, right? Your rise over run. And your geometric sequences are analogous to exponential functions where your base or your common ratio is that base of your exponential function. So we should be able to see some similarities here. We're going to talk about this more in just a bit. All right, so today we're going to be looking at series, and I'd like for you to write this in your notes, please. A series is a sum of the terms in a sequence. Of course, pause on the screen, hit continue when you've got that written down. All right, so if our sequence is 2, 4, 6, 8, 10, our series would be 2 plus 4 plus 6 plus 8 plus 10. And your series could be finite, it would just end there at your plus 10. Could also be infinite, where you could have 2 plus 4 plus 6 plus 8 plus 10 plus ... and go on forever, okay? We can write series using what's called sigma notation. So sigma is a Greek letter, S like sum. So first pause on the screen, go ahead and write the expression I have here. All right, so what this means is this letter n that you see on the bottom here is what's called your index, okay? So my expression of n squared minus 1, you're going to plug in n starting with 1, and then you're going to keep going up by positive integers. So you're going to do n equals 1, then you're going to plug in n equals 2, then you're going to plug in n equals 3, and you're going to stop there because that is the number above your sigma. Okay, so this expanded, if I plug in 1, I'd have 1 squared minus 1. Let me go ahead and write this. And sigma is S for what again? For sum. So then I'm going to add. Now I'm going to plug in 2 for n. So I have 2 squared minus 1 plus, and then I'm going to plug in 3 for n. So I have 3 squared minus 1. So I have, cleaning this up, I've got 0 plus 3 plus 8, which is 11, okay? I'd like for you to try one on your own. You do not need to simplify, but can you go ahead and expand this sum for me? And we don't have to use n for our index. Another really common index is k. You may also see the letter I for your index, but let's use k. And let's start at 0 this time and stop at 4. And do this for me. Let's do 2k plus 3. So go ahead and expand that for me. Again, you don't have to simplify it down to a number. Just expand it as a sum. And then hit continue when you are ready to check your answer. All right, so we should have gotten 3 plus 5 plus 7 plus 9 plus 11, or something equivalent. If you add all those up, you do get 35. A couple things I want you to notice. If you look at what I wrote in purple here, the 3 plus 5 plus 7 plus 9 plus 11, what kind of sequence is this if I took off the plus signs? It's arithmetic, right? Because I'm adding 2 each time. If you look at my expression here, if instead of the k you have an x, what kind of function would that be? That would be linear with what slope? slope of 2. So remember earlier I said whatever your slope would be in an arithmetic or in a linear function, that's going to be your d in an arithmetic sequence. Okay, the other thing I want you to notice is how many terms do you have in this series? You've got 5 terms. To find your number of terms in sigma notation, take your top term minus your bottom term and make sure you add 1, because if you just subtract, you're just getting the difference between the 2 terms and you're not accounting for that very first term, okay? Same thing here. If I do 3 minus 1, that's 2, but remember I've got 3 terms in here, so be sure to add 1. So top minus bottom plus 1. So go ahead and write that for me. So number of terms, if you're in sigma notation, is top minus bottom plus 1. All right? All right, let me also show you how to do this on a graphing calculator as well as Desmos. So let's take that same one we just did. We did the summation from n equals 0 to 4 of the expression 2n plus 3. When we added all that up, we should have gotten 35, so let's make sure we can know how to get that on the calculator as well. On the 84, go ahead and write this in your notes if you have access to an 84. You're going to go alpha, F2, or alpha window, and you can see it here, number 2, it says summation. And then you're just going to fill it in. I typically use X instead of N or K or whatever, just because it's easy to find. So I'm going to go X starting at 0, and then hit your right arrow ending at 4. And then my expression, I'm going to do 2x plus 3. And then I'm going to hit enter, and there's my 35. Okay, we can also do this on Desmos. You can go to your keyboard here. So pull up your keyboard, go to functions, it's under miscellaneous, and it's the sigma notation right there. You can also grab that if you like shortcuts. If you just literally type in sum, S-U-M, it's going to turn it to sigma. Now notice that they're using n here. So I'm going to go from n equals 0 to 4, open parentheses, of 2n plus 3 this time, and there's my 35. First pause on the screen, go ahead and copy this example, parts A, B, and C. Hit continue when you're ready to do them together. All right, so for part A, what we're going to do is we've taken this expansion, basically, and we want to rewrite in sigma notation, okay? So for this first one, I've got 5 over 1 plus 1, plus 5 over 1 plus 2, plus 5 over 1 plus 3, all the way to 15, okay? So I'm going to start by writing my Greek letter sigma for sum, and I'm going to go ahead and start at 1, and again, you can use your favorite letter. I'm going to go ahead and use N. So if I start at 1, where would you want to end? If I start at 1, I want my index to end at 15, okay? So now what we're going to do is we're going to take a look at each term, and what I like to do is say, okay, what does not change? Well, a couple things. The 5 in the numerator never changes, right? Also, each one has a 1 plus in the denominator. Now, the other term in the denominator does change. I go from 1 to 2 to 3 all the way to 15. Well, that's exactly what n does, right? It goes from 1 to 2 to 3 all the way to 15. So I can write this expression as 5 over the quantity 1 plus n. And that's it. Okay, so this is the expanded way to write the sum. This is the condensed way, or the sigma notation. All right, I'm going to give you a little bit of time to think about part B, see if you can figure out the pattern. Hit continue when you're ready to talk about it. Okay, maybe you're able to figure out the pattern. If not, let me give you a little hint. What I'm going to do is add 1 to each term. So let me see, if I were to add 1 to each term, I'd have 1, I'd have 8, I'd have 27, 64, 125, 729. Do these numbers ring more of a bell? These are the cubes, okay? So 1 is 1 cubed, 8 is 2 cubed, 27 is 3 cubed, 64 is 4 cubed, and so on and so forth. and 729 is 9 cubed, okay? So let's see if we can write our sigma notation now. So I've got the sum from n equals 1 to what? To 9. Now if I do n cubed, I would get exactly what I have in blue here, right? 1 plus 8 plus 27 plus 64, because everything I put in blue was each positive integer cubed, right? But then I need to go back and subtract 1, right, to get back to what I started with. And that right there, I'm going to go ahead and put it in parentheses so it is not ambiguous. That right there is the sigma notation for my expanded sum earlier. All right, let's look at C. If you'll notice, C, if I replaced all the negatives with plus signs, it would just be 1 plus 2 plus 3 plus 4 all the way to 13. So without the alternation there, it would just be n, right? As n goes from 1 to 13. But notice that you've got a positive, then a negative, then you switch back to positive, then negative. That's what's called an alternating series. Okay, so whenever you need your series to switch signs, what you want to do is do -1 and start by going to the nth power. Okay, so if I plug 1 in for n now, let's check it out. This would be -1 to the first would be negative, and then 1 here would be 1, which doesn't quite work, right? Let's keep going though. If I try 2 for n, this becomes +1, and then n is just 2. If I plug 3 in for n, this becomes -1 times 3, which is -3. And so I'm almost there, but I'm off by a sign, okay? So whenever you're off by a sign, you've got a couple options. What you can do is you could either lower your index and start at 0 and work with your expression here. But the easier way, I believe, is to just add 1 to your power here, because now when you plug in 1, your exponent here is 2, and what's -1 squared? +1. So you get +1 times 1, which is 1. Plugging in 2, I get -1 to the third, which is what? -1 times 2, which is -2. Next, I'd plug in 3. So I get -1 to the fourth times n, which is 3. So that is going to be +1 times 3, which is +3. And now we're on the right track, right? Now this is working for us. Okay. All right, so now what we're going to do is see if, just like we have a general formula for arithmetic sequences, can we come up with a general formula for arithmetic series, okay? And my favorite way to do this is to tell you about a story of a famous mathematician named Mr. Gauss. And we think when Gauss was, we're not real sure, but we think he was like 7, 8, 9, somewhere in there. He got in trouble at school, and his teacher said, "Little Frederick, you are driving me nuts. Go to the corner, and I want you to add the numbers, the integers, positive integers, 1 to 100. So 1 plus 2 plus 3, all the way to 100. And Frederick comes back in like a few seconds, and he says, "I've got it. It's 5,050. And the poor teacher starts adding all the values, and after several minutes, it's like, that is correct. How did he get it so fast? Here is what he did. I'm forced pause on the screen. Can you copy what I have, exactly how I have it? 1 plus 2 plus ... plus 49 plus 50, etc. So copy exactly what I have. Hit continue when you are ready to see this pattern. All right, so here's what little Frederick Gauss did. He took 1 plus 100, and he said, well, that is 101. So I'm done with those. And then he started working his way in. So next he took 2 plus 99, and he said, well, that's 101 as well, right? The next pair would be 3 plus 98, and that's going to be, whoa, 101. I'm struggling here. All right, and he's going to work his way in. He's like, okay, well, this pattern's going to continue, right? Until we finally get to 49 plus 52. This is ... Okay, there's another 101, and finally, I'm going to get to 50 plus 51, and that's 101. And so we end up getting 101. How many times? Well, 1 plus 2 plus 3 all the way to 50, right? So we end up getting 101 times 50, which is 5,050. And how would I write that in sigma notation? Well, I could take the sum from n equals 1 to 100 of just n, right? That would be 1 plus 2 plus 3 plus 4 all the way to 100, okay? Now let's talk about where this 101 and this 50 came from. Let's talk first about 50. Where did the 50 come from? The 50 is the number of pairs, right? In other words, it's your total number of terms divided by 2. Okay, so how many partners, right? And then where did the 101 come from the very first time? The very first time we found it, it was when we took the first term plus the last term, okay? It turns out this method that little gal discovered so young will work for us for any arithmetic series. So in general, if I want to find the sum, and we denote this as capital S sub n, so the sum of the first n terms of an arithmetic series, I'm first going to find the number of partners, right, the number of pairs, which would be however many terms you had. Like the last time we had our number of terms was what? Was 100, and then you're going to take that and divide by 2. So in general, you're going to take the number of terms you have divided by 2, because that gives you how many pairs. And then how do we find 101 the very first time? We took the first term plus the last term, okay? So for example, if I want to find the sum of the first 100 terms, I would take 100, I'm going to plug in 100 anywhere I see an n, 100 divided by 2, and I'm going to take the first term plus the 100th term. It doesn't have to be 1 plus 2 plus 3. It could be 2 plus 4 plus 6 plus 8, etc. This works for any arithmetic series. And force pause on the screen, go ahead and copy the example, hit continue when you're ready to do this one together. Okay, so I've got 11 plus 7 plus 3 plus negative 1 plus or minus ... negative 73. So would you say this is arithmetic? It is. And what would you say that your common difference, D, is? It's negative 4. Okay, so if I want to find the sum, if I come back to my formula here, I need to know for arithmetic, how many terms am I even summing up? And we don't quite know that yet, right? So like over here, I knew I was summing up 100 terms. But here, I don't quite know. I need to figure out what is negative 73. Is it the 100th term? Is it the 20th term? I need to figure that out first because my formula says the sum of the first n terms is equal to the number of pairs, so that'd be n divided by 2, times your first term plus your last term, right? Well, I know my first and my last term, but I don't know how many terms in total I have yet. So let's use our arithmetic sequence formula to find that out. Remember, that goes like this. A sub n equals a sub 1 plus n minus 1 times d. Make sure you're writing all this. All right, so I need to figure out what term is negative 73. So what I'm going to do is I'm replacing a sub n with negative 73, and I need to figure out what is n, which term am I on, okay? So a sub 1 is 11 plus n minus 1, n is what I'm looking for, and you said d was negative 4. So let's solve for n now. I'm going to subtract 11 from both sides, so that gets me negative 84, and then I still have n minus 1 times negative 4 on the right-hand side. Now, you could distribute. I think it'll be faster if you just go ahead and divide both sides by negative 4. So negative 84 divided by negative 4 is positive 21. And then I just have n minus 1 on the right-hand side. So adding 1 to both sides, I get that n is 22. So what did I just figure out? Well, I just figured out that negative 73 is my 22nd term. Okay? Why do I need to know that? Well, because for arithmetic series, I have to know how many terms in total because I need to divide that to figure out how many pairs or how many partners we have. Okay, so now we can come back to this formula, and we are now replacing, now we know what n is. What is n? N is 22. So the sum of my first 22 terms, I need to first take 22 divided by 2, which is 11. That's how many pairs. And then each pair is going to be the same as the first term plus the last term, or the 22nd term in this case, okay? So I've got 11 times the first term, happens to be 11 as well, that's coincidence, plus negative 73. So I'm just going to put minus 73 here. All right, so I've got 11 times a negative 62, and that is negative 682, okay? So when I add all these up, I get negative 682. Now always check for the reasonableness of your answer. Is it reasonable that your answer is negative? I think so, because we just have our first 3 terms to be positive, and then after that, all our terms after that are negative. So it makes sense that our sum is negative. Force pause on the screen, go ahead and copy the example, hit continue when you're ready to do it together. All right, so we know how to do this on a calculator. Let's see if you can figure it out without a calculator as well. Take a look at your expression inside sigma. If you replace I with x, 6x minus 4, is that function linear? It sure is. So that means that this series is arithmetic, where your common difference is 6, what would be your slope. If you're not convinced, just try writing some terms out. So let's start with I as 1. So when I plug in 1, I get 6 minus 4, which is 2. Plus, now plug 2 in for I get 12 minus 4, which is 8. Plug in 3 for I get 18 minus 4, which is 14. So see how I'm adding 6 each time? Okay, and then what would my last term be? Well, plug in 10 for I, and you'd get 60 minus 4, which is 56. All right, now how many terms am I adding up? I'm adding up 10 terms. Remember, top minus bottom plus 1. So 10 minus 1 is 9, plus 1 is 10. So I want to sum up the first 10 terms. I'm going to let you go ahead and plug that into our formula. Hit continue when you're ready to check your answer. All right, we should be getting 290. So my number of pairs is 5. And then each pair, as I add them up, will be 58. So I have 5 pairs of 58 at 290. All right, let's close with this example. It says how many poles will be in a stack of telephone poles if there are 50 in the first layer, 49 in the second, and so on, with 6 in the top layer. Okay, so we first need to figure out how many terms am I adding. Well, remember, top minus bottom plus 1. So how many layers will I have? I will have 45, because 45, because 50 minus 6 is 44, plus 1 is 45. First pause on the screen, see if you can figure out the formula to find the total number of poles without going 50 plus 49 plus 48 all the way to 6. Hit continue when you're ready to check. All right, we should have gotten 45 over 2. It is totally okay if you have an odd number of terms, and then times your first term plus your last term, which gives us a total of 1,260 poles. All right, y'all, that's all I have for today. I'll see you next time.